All right, so we're going to take a look at problem number 18, the big perimeter versus small perimeter square. And there's actually a really simple rule about this that we learned in 7th grade, but I am going to get you to that point and then I'll just tell you the rule. All right, so here's the thing. We have a big square and a little square. So let's draw one of each. Campbell, you should draw one of each. Get a pen, get a paper, start drawing. All right. I'm sure everyone at home listening to that loved that. So here's a little square, and then I'm going to draw a bigger square. And it doesn't have to be to scale. It just has to approximate a square. And so the first thing I'm going to do is let's assign distances. Let's assign distances, and let's keep them really easy to work with numbers. What is the easiest number? Oh my goodness.
We will be meeting in the library in about 10 minutes.
I guess I have 10 minutes to finish this.
See you then. Thank you.
So what is the easiest number to add, subtract, divide, and multiply? 1. So I'm going to say the small square has a side length of... So what is the area of this square? How do you find the area of a square?
1 times 1 is 1.
1 times 1 is 1, so the area of the square is 1. But the problem says that the larger square is going to have a side length that is 7 times. Now I know it says the perimeter, but the thing about the perimeter is the perimeter can only be 7 times the size if each side length is also 7 times the size. So what? Yes, Campbell, you are right. This side length is 7 and this side length is 7. Therefore, the area of the square is 49. And you'll see that, what did I multiply this 1 by to get 49? And I multiplied it by 7. Now, a little vocabulary, 7th grade vocabulary. This is called a scale factor. And scale factors are what you multiply a side length by to get the side length of a similar figure. Now, a similar figure, I'm going to have to back up a little bit further. A similar figure is a figure that has the exact same shape, has the exact same angles, but as another shape. However, it does not need to have the same size. Now, two similar figures can also have the same size. That would be a scale factor of 1, because when you multiply 1 by another number, you get the other number. And that is congruent. And you will laugh, children, I swear. But the 7th and 8th graders miss the problem that says comparing a congruent and similar shapes all the time. And you probably think that's funny. And Campbell said, because they're stupid. All right. Anyways, so here's the deal. And when I say scale factor, you multiply this times this. So when you look at the area is always going to be the scale factor squared times bigger. 1 times the scale factor squared, and the scale factor is 7. 1 times 7 squared is 49. Is a total of 49. So if I were to take another example, let's say I have a smaller square and a larger square where the larger square is 3 times. How many times bigger would the area be of the larger square?
3.
No, it wouldn't be 3, because the area is the scale factor squared times bigger.
9.
It would be 9 times bigger. And that's how scale factor works. So getting back to our question, let's reread the problem, make sure we're answering the question as it is laid out. The perimeter of a big square is 7 times the perimeter of a small square. What fraction of the area of the big square is the little square? In other words, how many of these little squares will fit into this big square? So it's what what is it? Well, it's Campbell's mouthing to me. It's 1/49. It's like, you don't have to explain it, Dad. It is 1/49. All right, now scale factors can also be fractions. And if you have a scale factor that is a fraction that is smaller than 1, you'll have a figure that is smaller. If you have a scale factor that is a fraction that is bigger than 1, like 3/2, then you'll have a figure that is bigger. All right, number 19. How many different amounts can be formed with 4 pennies, 3 nickels, 2 dimes, and 1 quarter using at least 1 coin? This is a tricky problem. It's actually really, really simple. But it doesn't look simple. And here's the thing. Are you able to make 1 cent? Yeah, with just 1 penny. Can you make 2 cents? Yeah. Can you make 3 cents? Can you make 4 cents? Yeah, 4 pennies, right? Can you make 5 cents? 1 nickel. So it's because I can make all of these numbers, is there a number that I can't make? No.
0.
I can't make 0 cents if I have to use at least 1 coin. So the smallest number is 1. What is the largest number I can make with all of these coins? All of them combined, because I can make every combination because I'm able to do these first 5 in a row, and I know I still have pennies, and I still have nickels and dimes. So combining them all together would be my largest possible. So 4 pennies is 4 cents. And I dropped the pen. So that's 4 cents. 3 nickels is 15 cents. 2 dimes is 20 cents. And 1 quarter is 25 cents. So let's add them all together. 25 plus 20 is 45. 45 plus 15 is 60. 60 plus 4 is 64. So I can make any combination or any value of money between 1 cent and 64 cents. Not a hard problem. It's just how you look at it that makes it tough. The last one in this set, the square shown is divided into 20 congruent rectangles. What's wrong?
Didn't say how many different.
Oh, it's 24. It's 64 because you can have every combination from 1 to 64. That's why. It is very simple. All right, number 20. Of course, Campbell's right. I should have reread the question, make sure I answered the question. All right, last one. The square shown is divided by 20 congruent. Congruent means exactly the same rectangles. If the perimeter of each of those rectangles is 63, and it says the perimeter, right? Perimeter is equals 63. Then what is the perimeter of the whole square? Now, here's the thing. And I'm going to make some equations here, and equations have variables, and variables are quantities that can go up or down, and because I don't know what they are yet. And the first one I'm going to say is that I know, let's call this side, oh, I don't know,
C.
A. And let's call this side B. I know that 20 side B's, or 20 times B, is equal to 1A. So I know that up front. Then, what else do I know? And I should also say, if I haven't already, when you put a number next to a letter, it means what operation is putting when they're side by side with nothing in between? It means multiply. It's kind of like the maths equivalent of an apostrophe and a contraction. We mathematicians, like writers, can be lazy, and we don't want to write the multiplication because we multiply a lot. So you can just put them together. So 20b means 20 times the quantity b. In this case, b is this short side length. Now, I also know that a plus b has to equal, not the perimeter, because the perimeter is all 4 sides added together. So 2 of those sides, A plus b equals half the perimeter, and half the perimeter is 31.5. So those are the two things that I know to be true. Now, at this point, there are two things I could do. I could show you the math way of doing this, or we can use some logic here. So we know that some number times 20 is going to equal that A, right?
1.5.
And Campbell's yelling at me 1.5. Well, if this is 1.5, and this is a little guess and check. If B is 1.5, that would make A 30. What is 20 times 1.5? Well, 20 times 1 is 20. 20 times 0.5 is 10.
It's 30.
It's 30. So I know that A is 30, B is 1.5. Now, I'm not sure I need that 1.5 anymore, because it says, what is the perimeter of the square? Well, the perimeter of the square, 30 times 30 is 900, but 30 times 30 is going to be the area. We want the perimeter, so it's 30 times 4. So the perimeter is 120. Thank you. I was thinking 30, because 30, all sides of these, so 30, so I have 4 of them. That makes... Now, just as an interesting exercise, the algebraic way of doing this, if A is equal to 20b, what can I write instead of A in the second equation?
20b.
20b. So we have 20b plus b is equal to 31.5. Well, if I have 20 b's and I add another b, how many b's do I have? You have a hive. No. You have 21. You have 21b. So you have 21b is equal to 31.5. And if I'm multiplying 21 and b together, what would I have to do to figure out what b is? Well, I'm multiplying 21 and b, and I'm getting 31. How would I go about doing that? Well, what's the opposite of multiplying b by 21?
Dividing.
By 21. So if I divide 31.5 by 21, would I figure out what b is? Campbell's nodding his head yes. So you could do this division. And I'm going to cheat here for a second. I'm just going to go out fairly quickly. Oh, it's 21. Thank you, Campbell. It's always nice to have someone to work with to check your work. So 31.5 divided by 21 is 1.5. So that means this b is 1.5, which is what we figured out in the first place.